Let's have a look at these questions here on slide 22 then. So an 8-kilogram rock is dropped from a 10-meter high cliff. How much GPE, gravitational potential energy, would it store at the top of the cliff? So the first thing we want to do is, if I look at my whiteboard, the first thing I want to do is work out how much GPE this has. Well, GPE equals mass times gravitational field strength times height, mgh. Okay, so mass is 8 kilograms. I'm just going to use 10. So I'm going to put 8 for mass. I'm going to use 10 for g just to keep things simple. And then 10 for the height. So 8 times 10 times 10 is 800 joules. 800 joules of GPE before it starts to fall. That's how much gravitational potential energy it has. How much kinetic energy would it have halfway down? So the total energy that this rock's going to have, we refer to as the mechanical energy. And that equals the GPE plus the kinetic energy. The two of those two things combined always add up to the total mechanical energy. So take a second, there's a slide back along, I can't remember what slide number it is, let's have a look. This slide here kind of talks about what mechanical energy is. It's the total energy that an object in motion has. And on Earth, if there are no external influences, the only thing that could cause something to accelerate is gravity, right? If you think about it, if there was no engines or anything like that, or you couldn't push or pull anything, the only thing that would cause something to accelerate would be gravity. So gravity, once it's kind of, I'm going to use this word, it's not really right, once it's used up, so the higher you are, as you go towards the ground, you're using up that gravitational energy which is stored, and you're kind of turning it into kinetic energy. And it's a direct transfer. So it kind of, the two of them combined add up to the total amount of energy. So let's go back to that question. The question is, how much would it have halfway down? So halfway down, this has gone from 800 joules to half of that, right? At the top, the kinetic energy would have been 0. So it's 400 plus 400 equals 800, right? At the top here, the mechanical energy equals 800, right? There's no kinetic energy. The kinetic energy is 0. That ball is not moving, or rock, sorry, is not moving. It's not going towards the ground. It has 0 kinetic energy. The only energy there is gravitational potential energy. So halfway down, half of that 800 turns into kinetic energy. So it's 400. Has 400 joules of kinetic energy halfway down. Okay, next question. How much kinetic energy would it have just before it hits the ground? Well, this time, if I go back to my equation, this one here, this time, this would be 0, right? GP would be 0 just before it hits the ground, so that must mean that kinetic energy has become 800. Yeah, so my kinetic energy just before I hit the ground would be 800 joules. And then D, what speed would it have just before hitting the ground? So we're using our kinetic energy equation. Kinetic energy equals half mv squared. Okay, so the kinetic energy just before it hits the ground was 800. The mass is 8 v squared. Okay, 800 is my energy just before, kinetic energy just before I hit the ground. Half mass is a v squared, so we solve for v. V would equal the square root of, would that be 800 over 4? So square root of 200 then gives me 14.1 meters per second is the speed just before it hits the ground. Okay. And then the last question, answers to C and D would be slightly smaller. Why? So basically it's asking us, why are we not? So when I said that we had 800 joules of gravity before stored, that would become 800 just joules of kinetic energy just before it's ground. Well, it's saying, why wouldn't that be exactly right? Well, in an ideal world, it would be. Yeah, you wouldn't lose any energy, but in reality, there's energy being lost as heat from friction through air resistance, and then probably a little bit of sound as well. So it'd probably be a little bit less than this, because it was 800 before. The total mechanical energy before was 800 up here, right? But the time it hits the ground is probably a little less because there's some energy that's lost to the surroundings. Okay, so that summarizes the answers to slide 22. So I get 800 for the first one, 400 for the second one, joules. These are both in joules. This one is 800 joules. The speed I got as 14.1 meters per second. And then the answer to part E is because some energy is lost to the surroundings as heat or sound.